Hey everyone, welcome to the 1.3 linear functions notes. Our goal for this lesson is to be able to determine if a function is linear and graph a linear function from 2 points, a point and a slope, or any equation. There are 3 forms we're going to talk about. So first things first, what is a linear function? That's how we determine, the definition is how we determine if it's linear. And a linear function needs to have a constant rate of change. Okay, this should sound pretty familiar to you. We also could call this the slope. And it doesn't matter which 2 points you pick on the line, the slope or rate of change between any 2 points should still be the same. Okay? So, for instance, on this first table, I'm looking at the change between 10 and 8. That's 2. 8 and 6. That's 2. 6 and 4. That's 2. Okay, and I'm going to go ahead and put a down arrow next to them because they're each going down by 2. Technically, the slope of this line would then be -2. Do come over here and make sure that these are changing by 1s because that does make a difference. So this function is linear because we wrote the same number each time. It had a constant amount of change each time. Over here, from 16 to 8, that's going down 8. From 8 to 4, that's going down 4. And from 4 to 2, that's going down 2. You can also think of it as how far apart are 16 and 8 on a number line. Or, if you really need to, 16 minus 8 is 8. 8 minus 4 is 4. And 4 minus 2 is 2. Okay, and these are also going down. So it would have a negative slope if these were all the same number, but they're not. So since that's constantly changing, it doesn't have a slope or a constant slope. So we would say that that is non-linear. There is a way to start talking about the slopes of these, and that actually leads you into what is called calculus. All right, let's talk about how to find slope. That is one way of looking at the table. Other ways are something called rise over run. And what that means is we're going to look at how far up a graph goes and then how far to the side a graph goes. Another way of saying this, and I'm going to write a symbol you may or may not have heard before, is y over x, and this little symbol out front that I wrote here means change in. So the change in y over the change in x. This symbol also gets used a lot in physics. Another way of finding this, these two are kind of understanding what slope is. The change in y is the rise, the change in x is the run. The formula for this, if you need it between 2 points you can't see the graph, is y2 minus y1 over x2 minus x1. And what this means is the y value of the second point minus the y value of the first point over the x value of the second point minus the x value of the first point. So these two should be a point, and these two should have been a point. And then let's go over the types of slope really quick. A line that goes up and to the right has a positive slope. Also realize that it could go down and to the left. A negative slope goes up and to the left or down and to the right. And a slope of 0 is a horizontal line, sort of got a flat slope. That is a slope, it's just a slope of 0. And if it has undefined slope, it is a vertical line. The easiest way to remember these is if you were to walk along this line left to right the way we read, then you'd be going up. For a negative slope, you would be going down. For a slope of 0, you wouldn't be going anywhere. You'd just be staying where you are, so 0. And for an undefined slope, if you try to walk on this line, it's like a cliff. You would fall off and be undefined. Okay? So now we're going to find the slope from a graph and then from 2 points. Let me kind of adjust this. There we go. So when you're looking at a graph, look for 2 points where it crosses in the corner. I've kind of marked them here. And then what you're going to do is look at how far you need to go up and then how far you need to go over to get to the next point. So going up, I have 1, 2, 3. And going over, I have 1, 2, 3, 4, 5. So my slope is rise over run. The rise was 3, the run is 5. And unlike in equations when we're solving them, it's actually kind of nice when slope is a fraction because that tells you to go up 3 over 5 to the right. And when I say over, I usually mean to the right. I will say left if I want it to be to the left. Okay, and then I'm going to do this problem in 2 ways. The first way, I'm going to do the change in y. My y values are the second part of each point, so the 5 and the 7. What is the change to go from 5 to 7? Hopefully you know that that is up 2. So my change in y is 2. My change in x goes from 4 to 1. That's going down 3. So I'm going to go ahead and call that negative 3. So my slope is negative 2/3. And really quickly, I'm just going to tell you that 2 over negative 3 is the same thing as negative 2 over 3 is the same thing as negative 2/3. It doesn't matter whether that negative goes bottom, top, or out front. They're all the same thing. Then I'm going to do it using the formula x1, y1, x2, y2. So every point always goes x, then y. I'm putting 1s on the first point, 2s on the second point. So I need to do y2 minus y1. That's 7 minus 5 over x2 minus x1. That's 1 minus 4. 7 minus 5 is 2. 1 minus 4 is negative 3. So I get the same thing no matter which way I do that. The only thing is this way requires a little bit more mental math. You have to be able to kind of count between the numbers. Okay, let's go over the 3 different equations that we could have. So the first one is standard form, and that's where x and y are on the same side. This helps you find the intercepts, and then you can graph it through the intercepts. The slope-intercept form, well, it helps you find the slope and the intercept, specifically the y-intercept, in that order. So slope is the m, and the intercept is b. So if you can remember slope-intercept form, that also is telling you that slope goes before intercept. Otherwise, it would be intercept-slope form, and it's not. Hopefully that sounds really weird to you because that's not what you've probably learned in the past. And then the third and least liked that we're going to talk about more in 1.4 is point slope. So you get a point and the slope. Okay? The point is the x1, y1, just like it was up here. And the slope is the m. So the slope is kind of sandwiched between the point and the slope, or the slope is in between the 2 parts of the point. There we go. Okay, let's actually start looking at some of the graphs here. So we are going to graph each line using the information given. Hopefully this part is like extremely easy for you guys. Start with the point, negative 2, 1, left 2, up 1. And then the slope, remember that this is rise on top. So that's going to go up 4. And then the 3 is the run, so that means it's going to go to the right 3. Okay, so I'm going to go up, and I know this is kind of hard to see, the graphs aren't the best. 1, 2, 3, 4, and right 1, 2, 3. And then I just draw a line through those 2 points. Done. Okay, let's do another one. -3, 4. Remember that x always goes before y. So we're going to go to -3 on the x-axis. -3, up 4. There's my point. And then my slope is -1/2. That negative means I'm going to go down 1. The 2 means I'm going to go right 2. Whenever I see a negative slope, I always go down and to the right instead of up and to the right. So I just switch from going up to going down. That's it. So I'm going to go down 1, right 2. And since that's kind of a small slope, I like to do it at least twice, so I have more points to draw my line through. So I'm just going down 1, right 2. Down 1, right 2. And notice how I'm also drawing my lines all the way across the page. Take up the whole graph with your line. Extend it until you get to the edge. Don't just draw it from here to here, because that's not going to give you a good idea of what the line actually looks like. Okay? Now, we're going to do a separate way of graphing. Notice how we have 2 equations. X and y are on the same side. What that means is it's in standard form. So I'm going to use the x and y intercepts. For the x-intercept along here, notice how we haven't gone up at all? So y is 0. And we're going to solve for x after we replace y with 0. Because the x-intercept is always something, comma, 0. And what I mean by that is literally go into the equation and change the y to a 0. And hopefully you know that -6 times 0 is 0. So now I have 4x equals 12. I'm going to divide by 4. X equals 3. Okay, this is my x-intercept. So I'm going to go put that point at 3 on my x-axis. For the y-intercept, it's very similar, but this time you're going to replace x with 0. Okay, so you replace the opposite variable with 0 so that you have the one you're looking for left. So I'm going back up here, but I'm changing x to 0, because that's going to give me the y-intercept, because along the y-axis, x is 0. So now, that's 4 times 0 is 0, and I just need to divide by -6. 12 divided by -6 is -2. And that is my y-intercept. Oops, almost messed that up. Okay, so I'm going to go to -2 on the y-axis, put a point there, and draw myself a line through them. All right, one more. I'm going to go through it a little bit faster this time. So you know that the other variable is going to go away. So one thing that you can do is just say, okay, 8x equals 40. And then 10y equals 40. So since you know that it's going to be 0 and just go away, you can just kind of skip it like that. Just like we crossed it out over here. Okay. And then I'm going to divide by 8. My x-intercept is 40 divided by 8, 5. And over here, I would divide by 10, leaving my y-intercept to be 40 divided by 10, 4. Okay. Do not combine these two and make them one point, because you need these both to be their separate points so that you can draw a line through them. Okay, it's sort of like picking a value and plugging it in, and we're picking the easiest number to plug in, which is 0. And then that gives us 2 separate points, and there you have it.